Hello everyone, welcome to my lecture. So in this lecture we will discuss about phonons in solids. So here we will study what are the phonons, a brief concept about phonon and how can we study the existence of phonon. এখানে আমরা যা পড়ব যে ফোনন জিনিসটা কি, ফোননটা কিভাবে আমরা বুঝতে পারি যে একটা সিস্টেমে বা সলিডের মধ্যে ফোনন আছে। ফোনন নামটা অনেকটা ফটনের সাথে সিমিলার, সো সেইভাবেই আমরা দেখব যে এটার প্রপার্টিও অনেকটা ফটনের মতোই সিমিলার। সো অ্যাকচুয়ালি direct we cannot observe the phonon, but we have indirect experimental observation. So firstly we will study what is a phonon, a brief idea, then some properties, and then how we can establish or we can indirectly observe prove that phonon exists. So firstly you know what is photons. You know that the energy of electromagnetic wave is quantized. You know electromagnetic energy or radiation energy ta quantized thake, we know from quantum theory. So energy of electromagnetic wave quantized, which we called photons. So we have to, so if nu is the frequency of the electromagnetic wave, then we have the energy quanta as h nu. Similarly we define the phonon. How we define the phonon? The energy of lattice vibration, or you can say elastic wave traveling in the lattice is quantized, and this quantum of energy, this quantum of lattice vibrational, or you can say mechanical energy, is the phonon. So what is phonon? Phonon is the quantum of energy of lattice vibration or elastic wave in a solid. Okay, so a phonon, so phonon ta ki similarly electromagnetic wave যেভাবে এনার্জি কোয়ান্টাইজ থাকে, যেটাকে আমরা লোয়েস্ট মিনিমাম কোয়ান্টাম অফ এনার্জি যেটা থাকে h nu, যে কোয়ান্টাম অফ এনার্জিকে আমরা বলি ফোটন, সেইভাবে লেটিস ভাইব্রেশন এনার্জিটাও কোয়ান্টাইজ থাকে এবং তার মিনিমাম কোয়ান্টাম অফ এনার্জিটাকে আমরা বলি ফোনন। সো এ ফোনন, আর ফোননটা সলিডের মধ্যে ট্রাভেল করে, তো তার একটা ইম্পর্টেন্ট প্রপার্টি হচ্ছে ফোনন ট্রাভেলস in a solid at the speed of sound in that solid বা মিডিয়াম। তো সাউন্ডের যা ভেলোসিটি হয় সেই ভেলোসিটিতে ফোননটা ট্রাভেল করে। ইফ ওমেগা ইজ দি অ্যাঙ্গুলার ফ্রিকোয়েন্সি, ওমেগা যদি অ্যাঙ্গুলার ফ্রিকোয়েন্সি হয় ফর এ মোড অফ ভাইব্রেশন, একটা পার্টিকুলার মোড অফ ভাইব্রেশন অফ দ্য সলিডস লেটিস ভাইব্রেশন যদি ওমেগা হয়, দেন energy of a phonon is E equal to h cross omega or h nu. Nu is normal, nu is the frequency, this is angular frequency, this is linear frequency, 2 pi nu হচ্ছে quanta of lattice vibration, that is phonon. So ঠিক আছে, মনে থাকবে। তো ফোনন ডেফিনেশন যদি আসে বলবে ফোনন is a quantum of lattice vibrational energy or elastic wave in a solid. Energy is given by h cross omega, where omega is a mode of angular frequency for a particular mode of vibration. If there is n number of phonon, then total energy will be E equal to n h nu or n h cross omega. Okay, so this is one of the property. Another property is phonon is very similar to photon, has zero charge. It has no charge or zero spin, so it obey BE statistics, means they are bosons. Okay, so average number of phonon at a particular temperature, at temperature T, is given by Bose-Einstein statistics e to the power h nu by kt minus 1, or if you write in terms of h cross omega by kt minus 1. Okay, so it follows Bose-Einstein statistics. So you have phonon very similar to photon. This is quantum of electromagnetic wave, this is quantum of lattice vibrational energy. Its formula is very similar, where omega is the angular frequency of a particular mode of vibration, and it follows Bose-Einstein statistics. It's a zero charge or spin. So now all types of lattice vibration, যত প্রকারের ল্যাটিস ভাইব্রেশন থাকুক না কেন, তারা কোনো না কোনো ফোননের জন্যই হবে। Or indirectly you can say that all type of lattice vibration are associated with phonons. So ultimately actually lattice vibration is a phonon vibration or phonon phenomena. So all types of lattice vibration will be associated with some kind of phonon. So we can classify few type of phonons, like say we can have acoustic phonon. So what is acoustic? You know acoustic is related to sound. So acoustic phonon, these are the phonon that are associated with sound wave or acoustic vibration. Okay, so when we will say that so acoustic phonon, this will be related with the sound waves or acoustic vibration. So in this mode of vibrations, so when mode of vibration is such that atoms moves out of their equilibrium position, means they vibrate in such a way that they moves out of their equilibrium position in phase. So they moves in together collectively in phase. So say some atoms come closer together at some place, at some other place some atoms together moves far apart. So they are synchronized movements. So here we have synchronized vibration or displacement from the equilibrium position. This is very similar to the sound wave compression and rarefaction. So this we call, hence the name acoustic. So here the vibration or movement or displacement from the equilibrium position is in phase. So in some places some atom will move together closer, and some other place, at some other place they will move further apart. So there will be synchronized movement similar to sound wave. So here we have acoustic phenomena. So this type of mode of vibration will give rise to acoustic phenomena. Now we have optical phonon. So optical phonon, it is related with optical vibration. So here what happens, it represents such kind of lattice vibrational mode where atoms moves out of phase from equilibrium. So whenever they are displaced, they always move out of phase. So that means say cation we have cation and anion. Cation moves left, anion moves right. So here if both cation and anion are displaced from the equilibrium position, so if cation moves to the left, anion will move to the right. So they moves out of phase, so they are in phase. You should remember this. These are in phase, out of phase. So why this happens? Because say an electric field is applied to the crystal, so cation will move along the direction of the field and anion will move opposite to the field. So hence the name. This corresponds to the electromagnetic vibrations, or it relates with the optical phenomena. So this is optical phonon. Okay, another is thermal phonon. So this name suggests. So what will be the thermal phonons? Thermal phonons means at absolute zero, what happens? Crystal lattice, no vibration. So no vibration means no phonon. So if temperature increases, vibration occurs and we have phonon creation. So by temperature can increase or decrease phonon. So this is temperature dependent phonon creation. So they are called thermal phonons. The phonon resulted as a due to thermal energy. So generally the thermal energy of solid will be equal to energy of thermal phonons. Okay, so we have thermal phonons means the phonons that are generated or related to the thermal energy of the crystal lattice. Optical phenomena is due to the optical vibrations, and acoustic phenomena is associated with the acoustic vibrations. So they move in phase, out of phase. Okay, so these are the three types of phonons we will be concerning with, and phonon is a quantum of energy of lattice vibration. Okay, now we'll discuss some points for experimental evidence for existence of phonon. Actually, phonon is not directly observable as seen in as observed for photons directly. Like say in photoelectric effect, you can directly verify the existence of photon, but direct experimental evidence for phonon is not available, but indirect evidence is available. First one is the thermal specific heat, or the lattice specific heat tends to 0 as temperature tends to 0. As temperature is lower, approach 0, lattice viscosity tends to 0. This implies that some kind of quantization is there. So this is only explained if the lattice vibration is thought to be quantized in some form of, we say that, phonons. Okay, so specific heat, lattice specific heat tends to 0, temperature tends to 0. This is explained if you can take a quantization of the lattice vibration and some form of quantized energy, which we call as phonon, and energy is given by h cross omega, where omega is the frequency of the mode of vibration. Now second is, now X-ray, neutrons, etc. can be scattered inelastically by crystals. Inelastically means incident energy and outgoing energy will be different, or incident wave vector, outgoing wave vector may be different. So there will be inelastic scattering of X-ray or neutron by a crystal. So we can measure the change in energy due to scattering. Okay, and it is observed that and it is found that the change in energy is not continuous. Even if we change the energy of the incident wave continuously, the change in the after scattering, the change in the energy is not continuous, rather it is in the form of some kind of gain or loss of one or more basic quanta of energy. So gain or loss of one or more. So it is found that the change in energy is not continuous, but it can be defined in terms of some form of quantum of energy. Either if there is decrease in energy, this decrease is given by some integer number of some quantum of energy. If there is increase in energy, it is given by some form of quantum integer multiple of some quantum of energy. So it implies that there is some kind of quantization of lattice vibration, which later on the name is given as phonon. Okay, so these two you have to remember. If the question is asked, then how can we get the experimental evidence that phonons or some kind of quantization of the lattice vibration occurs similar to that of electromagnetic wave. Okay, so we have studied the photon and we have studied the phonon, which is very similar to photon, but there may be some differences. So the similarity, you know, the energy is quantized, and this is lattice, energy is quantized. So this is also energy is quantized. Okay, so its energy form is very similar. H cross omega is also very similar. It is the frequency of the electromagnetic wave, and this is the frequency of mode of vibration. It is frequency of EM wave. Okay, both obey BE statistics. Zero spin or charge. They have BE statistics, zero charge. Zero spin means integral spin. Okay, zero charge, integral spin. Okay, so these are very similar. Now there may be some dissimilarity also, which you can remember if sometimes it is asked. Dissimilarity, this is similarity, this is dissimilarity. Dissimilarity, one is that phonons mainly exist in solids because it is associated with the elastic wave or lattice vibration, but it exists in any medium. Okay. Now second one is it is equal to velocity of phonon equal to velocity of sound wave in the medium. Obviously you know this velocity of light. Okay, another is the momentum, that is slightly different. So here you know phonon has a momentum P equal to h cross k, E by c, h nu by c, h by lambda. So all these are applicable for both of a dual nature. So this, but no real or physical momentum. So this is important. Here we don't phonons don't have any real or physical momentum. It has physical momentum, but here we have a different type of momentum, the virtual momentum. How? phonons can interact with other phonon atoms or fields, and it behaves like having a momentum P equal to h cross k. This momentum is called crystal momentum. This momentum is due to the interaction of the phonons with the other phonons or atoms or fields, or with the lattice. This is the interaction of the lattice vibration with the field, phonons or other atoms. Okay, so it appears that phonon has, or you can say it is like h by lambda. So this phonon with wavelength lambda will have some momentum h cross k inside the crystal. So that is the crystal momentum. So this is real momentum, this is crystal momentum. Okay, so up to this much we have the concept of phonons. So phonons are quantum energy of lattice vibration. They have energy is cosine. They are very similar to phonons. Energy is quantized and the statistics like this. So they are acoustic phonon, optical phonon and thermal phonon. There are some experimental evidence like from the conservation, like changing energy of inelastic scattering and specific lattice specific heat capacity tends to 0. This also indicates some kind of condensation. So this you remember, this will be sufficient for a basic idea of phonon. In next class we will study about lattice heat capacity.